Okay, in the last unit we looked at how to find derivatives using the limit rules. In this next unit we are going to begin to look at some rules for differentiation that allow us not to have to use those limit rules every time to find derivatives. Now each of the rules I'm going to show you can be proven using the limit definition. If you'll refer to the recordings or the short clips from the National Repository of Online Courses, you can see some of these proofs. The first rule we want to look at is the derivative of a constant function. The derivative of a constant function is always equal to 0. The reason that's true is that what we're looking at when we have a constant function, y equals c, is a horizontal line. The constant function y values never change, and the slope of that line is 0 at every point. When we find a derivative, we are actually finding the slope of the curve, and so the slope is always 0. That tells us that if you look at the examples to the right, the derivative of -4 is going to be 0, and the derivative of 1,000 is also going to be 0. Next we look at the power rule. If n is a real number and x is a variable, the derivative of x to the nth power is n times x to the n minus 1 power. What that means is we're going to take our exponent and it's going to become a coefficient, and then we're going to subtract 1 from the exponent. So if we differentiate, take the derivative of x to the 3rd power, then that means we're going to make the 3 a coefficient, and we're going to subtract 1 from our exponent. Of course, 3 minus 1 would be 2. So the derivative of x cubed is 3x to the 2nd power. Now that works even if our exponent is not an integer. If we have x to the 2/3 power, that is going to be 2/3 x, and then if you do 2/3 minus 1, you will get -1/3. Now we can leave that in that form. If we want to write that with a positive exponent, remember that we move the x to the 1/3 power to the denominator. That will make it positive. If you also remember, x to the 1/3 power is the same as the cube root of x. So this is the same as 2 divided by the cube root of x. So those are just some different notations for that answer. If we take the derivative of x raised to the square root of 2 power, then the square root of 2 will become our coefficient, and we'll have x raised to the square root of 2 minus 1. Now remember, square root of 2 and 1 are not like terms and cannot be combined together. Next we have the derivative of 1 divided by x to the 4th. Well, if we will think of that in this form, that's the same as the derivative of x to the -4 power. Then we can say -4 times x and subtract 1 from -4, and you will get -5. We can leave it in that form, or we can make it -4, and to make the 5 exponent positive, we will place it in the denominator instead of the x to the 5th power in the denominator. So -4 divided by x to the 5th power. If we take the derivative of x to the -4/3, -4/3 will become our coefficient, subtract 1, or 3/3 from -4/3, and we'll have -7/3. And again, we can leave that in that form, or we can make it negative. We have 4 in the numerator and 3 in the denominator, and if we want that exponent to be positive, we'll make it x to the 7/3 in the denominator. So either notation will work. Another rule we need is the constant multiple rule. What that tells us is if we have a constant times a function, then its derivative is the constant times the derivative of the function. What that means is if we take the derivative of 3x squared, that's the same as 3 times the derivative of x squared. Or 3 times, remember the derivative of x squared, we bring the 2 out and make it a coefficient, x. 2 minus 1 is 1, so we have x to the 1st power, which is an understood 1. 3 times 2x is 6x. So the derivative of 3x squared is 6x, and that's the constant multiple rule. What that tells us is if we have the graph of y equals x squared, as you see in yellow, and the graph of y equals 3x squared, as you see in blue, and you think about the tangent lines at any given point, then if we look at x equals 1 on our original y equals x squared graph, it has a slope of 2. If we look at x equals 1 on the graph of y equals 3x squared, the slope is y equals 6, or triple what the slope was at the same x value for our original graph.